When doing exercise, you can often meet a result with a lot of decimal, and you can feel how to write the answer. This lesson will offer you some ways to handle it. This lesson is quite simple, but it's good for your vocabularies, so you should read many times. Lesson 5. Approximate numbers. Uncertainties. Part I. Approximate numbers. Example 1. To calculate the area of a circle with radius r equals 2 cm with the formula s equals pi times r squared. Nam takes an approximate value of pi equals 3.1 and gets s equals 3.1 times 4 equals 12.4 centimeters square, and MØNH takes an approximate value of pi equal 3.14 and gets s equal 3.14 times 4 equal 12.56 centimeters square. Since pi equals 3.14159 to 653, etc., is an infinite non-repeating decimal, we only get a finite decimal as an approximate result of the problem pi times r squared. Exercise. Do you think the following facts contain exact or approximate numbers? The radius of the equator of the Earth is 6,378 kilometers. Do you know what is equator? Equator is the longest latitude of the Earth. The distance from the Moon to the Earth is 384,400 kilometers. The distance from the Sun to the Earth is 148,600,000 kilometers. Such quantities as the radius of the equator of the Earth and the distance from the Earth to the planets are measured with special methods and devices. The results of the measurement depend on methods and devices used, so they are usually approximate numbers. We get only approximate numbers during measurement and calculation. Part II. Absolute uncertainties. Absolute uncertainties of an approximate number. Example 2. Let us determine whose calculation of the area of the circle with radius equals 2 cm is more accurate. Names s equal 3.1 times 4 equal 12.4, or means s equals 3.14 times 4 equals 12.56. We see 3.1 is less than 3.14 and 3.14 is less than pi. Thus, 3.1 times 4 is less than 3.14 times 4, and 3.14 times 4 is less than pi times 4, or 12.4 is less than 12.56 and 12.56 is less than s, and s is less than pi times 4. Therefore, MØNH's result is closer to the correct result or more accurate than NUMBERS. From the above inequality, we infer the absolute value of s minus 12.56 is less than the absolute value of s minus 12.4. We conclude that the absolute uncertainties of MØNH's result is less than NUMBERS. And the conclusion, if A is an approximate number of the exact number A with a part of its I call A part, then delta A equals the absolute value of A part minus A is called the absolute uncertainty of the approximate number A. That means the absolute uncertainty is the result of the subtractions between your result with the exact result. For example, you predict your exam score is 7, but it is A, so the absolute uncertainty is A minus 7 equal 1. Second, the accuracy of an approximate number. Example 3. Can we determine the absolute uncertainties of the results of the calculation of the area of the circle by NUM and MØNH in the form of decimals? Because we cannot write the exact value of s equals pi times 4 in the form of infinite decimals, we cannot calculate the absolute uncertainties. However, we can approximate them. We have 3.1 is less than 3.14. 3.14 is less than pi, and pi is less than 3.15. Therefore, 12.4 is less than 12.56, and 12.56 is less than s, and s is less than 12.6. From that, we infer the absolute value of s minus 12.56 is less than the absolute value of 12.6 minus 12.56 equals 0.04, and the absolute values of s minus 12.4 is less than the absolute value of 12.6 minus 12.4 equals 0.2. We conclude that the absolute uncertainty of MØNH's result does not exceed 0.04, while that of NUMBERS is not greater than 0.2. In other words, the accuracy of MØNH's result is 0.04, while that of NUMBERS is 0.2. The conclusion, if delta A equals the absolute value of A par minus A is less than or equals D, then negative D is less than or equals A par minus A, and A par minus A is less than or equals D, or A minus D is less than or equals A par, and A par is less than or equal A plus D. We say A is the approximations of a part with the accuracy d, denoted by a part equals a plus minus d. The exercise: compute the diagonal of a square with 3 cm size length and determine the accuracies of the computations result given the square root of 2 equal 1.41421335. You should try to solve this exercise. Note: the absolute uncertainty of an approximate number obtained from measurement sometimes does not reflect the accuracies of the measurement. Consider this example. Astronomers calculate it takes the Earth 368 days plus minus a quarter days to complete its revolution around the Sun. Nam calculates it takes him 30 minutes plus minus 1 minute to travel from home to school. Which of the above is the more accurate calculation? The absolute uncertainties of astronomers' measurement do not exceed a quarter days. That is to say 6 hours or 360 minutes, while that of Nam's is not greater than 1 minute. At first, it seems to us that Nam's measurement is more accurate than astronomers' 1 minute compared with 360 minutes. However, a quarter day or 360 minutes shows the accuracies of the measurement of one movement in 365 days, while 1 minute shows that of one movement in 30 minutes. Comparing two reasons, the whole 1/4 over 365 equals 1/1460 equal 0.0006849, and 1/30 equals 0.033, etc. We must acknowledge that astronomers' measurements is far more accurate. Thus, besides absolute uncertainties delta A of the approximate number A, we have to consider the reason delta A equals delta A per absolute value of A. This is delta A normal delta A and is the capital delta, where delta A equals relative uncertainties of the approximate number A.